Good afternoon, Victoria. Glad someone's here. It's only supposed to be 6 people, I think. That, that's what it said beforehand, anyway. And, how many were waiting? We'll see in another minute. Oh, uh, yeah, we just got you. The others will be here soon, I'm sure. But Top Hat Bot is there. Well, I've got, it says 3 online. Oh well. It's our starting time, so I'm going to move ahead anyway. A class of 1. Um, anyway, so at least for you, Victoria, that update on things that I'm still marking stuff. I don't think I've got any old stuff of yours, but I'm trying to remember. But I've got a bunch of assignments that were resubmitted, some assignments that went directly to me that I still got to get marked. And da, 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 that a few people have told me that they missed tests or quizzes, and I'm still trying to reset that. I know there's one person that just emailed me, and I've got to get things turned on after class for her. Anyway, with today's class, it's not going to be super long, probably just an hour. And I want to end up evaluation. And then next Wednesday, we do the last topic, which is deployment. And in this instance, will be primarily about uh, if you're writing a report and what your recommendations are, how do you put it in a persuasive fashion so that the readers of your report will accept your recommendations and believe you? And it's a skill that's really, really important, but one that's not an explicit portion of any course that we teach. So hopefully you develop the skills over time during your program. But I think it's a gap that we've got that we need to improve your. Some students are really good at report writing, but a lot can use an awful lot of help. And if I can help you out a little bit this term, it should help you with other courses later. And it definitely will make a difference after you graduate, because lots of people do awful reports. So I should switch back to my message version of chat. Where am I back again here? I can, every time I flip it, in terms of seeing who's here and who isn't, it flips me out of the presentation. Um, and just to give you a heads up, or anyone that watches this video after we record it, that I will be putting a survey out probably the end of the week to try to get feedback on the course, on a variety of things, part on the content, part on the way it's delivered, the top hat medium that we've used. I'm particularly interested in how I've structured evaluation with still people are asking me, when's the final exam? There's no final exam. We have no exam. That on Saturday, or earlier, you will do the final quiz. And after that, you've got assignment 5 for Friday and the last quiz, and you're finished. And I've just got to get marking done. Uh, I think I'm probably required to get grades submitted somewhere around the 15th of the month. And that gives us about a week to 10 days to get my marking done. Um, Before I get that finished, I'll probably try to communicate with everybody what I think your interim grade is and what, if anything, might still be missing, and so that we can make any revisions that might need to be made before I submit the actual grade on the 15th. But that's my target date. And if there are any errors or omissions, we should try to get them resolved by then. So I think that's it. Uh, So let me get underway. Has anybody else joined the class, or is Victoria still by herself? Nobody's typing. Oh, Matt's typing. I'm here. Good. Okay. That it said that there were 6 students waiting, but it seemed Victoria was the only one that initially showed up. Uh, anyway, uh, and you're still here. uh, really cold morning. Uh, no, she's not hogging the spotlight. It's just there's nobody else there. Um, they anyway. Uh, so this morning it was super cold out. I had to go out early this morning to drive over to Dartmouth, and um, before I left, I was looking out upstairs window, getting dressed, and this is what the view was. It was actually more colorful, but my phone just doesn't pick up the color when it's got a dark surrounding around it. But it was a beautiful morning, just so cold, frost on the cars and everything. Anyway, that in the 11:30 class, one of the students greeted me with "Good evening," and I asked, well, "Where are you?" She's in Kenya, so a little warmer there than it is here. She said it was cold there. I can't imagine that. Anyway, so today we're doing evaluation still, and um, I want to look at repetitive decisions. And this is important for us because so many of our decisions are ones that we're going to make not just once, but many times over. And when you're dealing with repetitive decisions, we've got other tools available to us to evaluate things rather than just using the rates that we had last class. I found those rates, they're informative, but almost overwhelming and sort of paralyzes you. What do I do with this information now I've got it? Is this a good model or not a good model? How do I make a compelling decision about that? So let me start with a simple one. And we've got a marketing promotion we're going to send out to our customers. It's really cheap to send out. It only costs 10 cents per customer to send it out. So it's a very inexpensive medium that we're using to do our marketing. And if they buy the product, then we anticipate to realize a profit of $15. Good. But if they don't, we'll have wasted our 10 cents. And suppose only 1 in 100 customers is likely to buy the product. That's still quite a few. It's actually a lot. Um, and we could ask, is this promotion a good idea? So if we went through this, we would be talking about not just one customer, but a broad spectrum of customers. We know some will buy and some will not. And so we could look at um, taking that approach that I've been suggesting before when dealing with probabilities to make it concrete. Imagine you're sending it out to 100,000 customers. And so what's going to happen? Out of 100,000, 1 in 100 buy it. So that's 1,000 customers, approximately, will buy it. And at $15 each, that's $15,000 in profit. Good stuff. And but we would also expect 99,000 to not buy it, and we'll have lost 10 cents on each one of those. So that's maybe 10 cents isn't much money, but times 99,000 people, that's $9,900. It's a lot of money. But in the end, though, I've got a net profit still of just over $5,000. So it's a good idea. I'm going to make money with this. Not from every customer, but that small group that are going to buy it, I'm going to be able to reach them, get them to buy, and I'm ahead. On a per customer basis, it makes a profit of about 5 cents, which isn't very much money per customer, but over 100,000 customers, that adds up. So even a small number, if you're multiplying by a big one, you may get a big number in the end. So making my $5,000 profit, but making on average only a tiny amount of money from each one. And you you, you may want to think that, but I don't make 5 cents off of any customer. I either lose 10 cents or I make $15. And so this is an average, but it never represents any specific outcome. But I think we can understand the idea of the average. This average is given a formal name in statistics and probability, and they call it expected value. Uh, like a lot of pieces of jargon we use, I'm not sure if it's the greatest name, but you had to call it something. And we probably couldn't call it average because we already have average for other types of things. And this is sort of a more theoretical type of thing. And it's taking each of the outcomes you're going to get times the probability of the outcome, and you multiply those and add them all up, and you get your result. So $15 times the chance of getting $15, that's 0.01. And from that, I've got the loss from not getting a profit, the minus 10 cents times the probability of 0.99. And when I do all of that, if I did my arithmetic correctly, then I'm not sure if I did. Anyway, by the looks of things here, I get 0.051 as being my answer. Okay? So that represents my expected profit per customer. Um, it may be awkward to get your head around, but this is a very, very widely used measure of performance in any type of repetitive decision making when risk is involved, when probability is involved. Uh, Eventually, you're going to take finance, and they'll talk about this to do with investments, because when we make an investment, we aren't sure what we're going to get back in terms of profit or return on our investment. It's random as to whether or not the market goes up or down or that type of thing. But it's presumed with investments you're making many, many, many little choices, like you could always buy or sell every day. And so you could think of, even if you're buying and holding for a year, that's like having made 365 decisions. Some days your investment's going to go up and some days it's going to go down, but on average, how will you do over the course of a year? And so they'll talk about expected value. So that the last example, I had it going out to everyone. And I analyzed my 100,000 customers or whatever. But suppose I don't send it out to everybody. Suppose I've got a classification model to predict who is likely to buy and who is not likely to buy. And so I'm only going to send the promotion to those I think are likely to buy it, and I'm not going to send it to the others. And my model came up with a list of 2,000 names out of the 100,000 and said these 2,000 are the ones likely to buy it. Okay. And that I'm going to send the promotion to those ones. So you can see here that of the people I send the promotion to, less than half of them actually go and buy it, and a little more than half of them don't buy it. But among those that I didn't send the promotion to, I get almost every one of them. So we can look at these different ways. And I can build the confusion matrix here around all these customers. And I can now evaluate whether my model is a good model or not a good model. That even though I'm sending it to lots of people that are not going to buy it, I'm sending it to an awful lot of people that will, and saving the cost of sending it to the losers, the ones that aren't going to buy. And so in my confusion matrix, I've got all of these probabilities. I've got a typo here on the right. I didn't get a chance to fix between classes. This should be 0.02 and 0.98, right? It's only to 2,000 customers, not 20,000. Anyway, so I'll fix those typos. That and here are all the other probabilities that we had here. See, like if I add these two numbers together, I get 0.02, not 0.2. And so if they buy and I send the promotion, I make a profit of $15. If I send the promotion and they don't buy, I lose 10 cents. If I don't send the promo, but they would have bought it if I had said it, I get nothing because they never got the promotion, so they didn't know about the product and they didn't buy. So I've lost out on them, but it's zero. I didn't lose money. I didn't make money off of it. And that sending it out and they don't buy, well, good. I didn't incur any cost. I would not have generated any profit because they wouldn't have bought. And so I've got all of these things here. And for the most part, it's my only opportunity I've lost out on is these 98 that didn't buy, but I've incurred a cost on these 1,098 that didn't buy because they didn't want it. I can work out expected value. So I take the value times the probability, the outcome times the probability. These ones here are simple because the outcome is 0 times their probability. And if my math is right, I get an expected profit of 0.1342. That's 13.5 cents instead of 9.5 cents, or no, 5.1 cents that I had before. So it's about 8 cents better per customer, which multiplied by 100,000 potential customers, that's $8,000 extra that you get with the model. So doing nothing, that is a profit of $5,000. But if I use the model, my profit increases to $13,000. It's a lot better. I can look at, how good my model was. If you measured sensitivity, you find it's 90%. That they, among those that are going to buy, I got captured 90% of them. So I got most of the possible profit. And among those that were not going to buy it, I predicted they're not going to buy it most of the time, 99% of the time. So the specificity was very high at 99%. That I could also look at the false discovery rate or the false omission rates and work those out. And last class, it was sort of, okay, is that good? Is it not good? It's not putting it in financial terms. It's sort of like when we did the regression analysis and you had an R-square, which might sound really good, but the standard error tried to put that error that you had in concrete terms, in terms of how far off you might be in real numbers that you could work with. And you could decide can you live with a forecast that's off by 100 or 200 or 300? So expected value implicitly is taking account of a lot of these different performance measures. We've got these different rates and putting it into financial terms. And on average, what sort of profit you're making or what sort of loss have you got? And in that sense, it makes it attractive to a lot of business people. But you have to realize you're not going to realize a profit of 5 cents or 13 cents on each and every customer. On some customers, you're going to get $15, and some customers, you're going to lose 10 cents. Got this trade-off between the two. And you're going to have a lot of customers, potentially, that you're going to lose money on. But the ones you're making money on easily offset that. Now, with this one, it was simple because two of my outcomes had no dollars associated with them. That sometimes all 4 cases, or at least 3 cases, have dollars associated with them. So let's look at one where there's more consequences than we've got, particularly in not in this one, there were really no consequences one way or another by making a decision not to send the promotion because we didn't think they were going to buy. What What if there were consequences to making that alternate decision? So let's look at one that's with credit cards and credit card fraud, and have a similar situation where now I'm going to assume that 1 in 100 transactions is fraudulent. Like before, I had 1 in 100 was good results, people buying my product. Here I've got 1 in 100 being bad results, and I'm going to lose money because it's fraud that's been committed on me. And I'm focused not on identifying who's going to buy. I'm focusing at this time on who's giving me a fraudulent transaction and which ones are a good transaction. And I've got a classification model for it. Okay. That and I think this one I used in a previous class to do with measuring all of our different rates. And it wasn't class 20. It was, I think it was just last class, it was 21. Anyway, that they, if I'm looking at these, that you'll see that I still have a significant number of cases of fraud. And I've got a significant number of valid transactions I'm going to reject. So think through what are the consequences of the different types of things we've done and when I've made a mistake or when I've got a right answer. So let me look at if it's a valid transaction and I approve it. I make money on these. This is what the whole credit card business is about. When you go and use your Visa card, they charge the retailer a fee for giving them money and absorbing the risk associated with that transaction if you're really going to pay for it. So in a sense, it's the bank now loaning the money to the customer and not the retail store loaning that money to the customer. So there's no risk there for the customer or for the retailer, for the store. And they get charged a fee for that of 2 to 3%. It can be quite substantial. That's a lot of money when your margins are small. And so I get that money as the bank, get that money. So if you bought something for $500, then 3% of that is $15. I'm going to make $15 profit on that. And in addition, if you don't pay off your balance, I'm going to make interest off of the customer. So I got money from the retailer and I'm going to take money from the customer. And so I make a profit on every valid transaction that I've approved. And I'd like that number to be really big. But what about the fraudulent ones? Well, let's suppose the average fraudulent transaction ends up costing me $500. I'm not sure what the figure would be. Both of these numbers I should be able to estimate reasonably accurately from my own accounting records. So they're numbers that are not just made up. I should have historical data that would give me an idea of average purchase amount, average fee charged to the retailer, average amount of interest I'm earning per transaction from a customer. That and then I've got to look at, and similarly with the on average, how much am I losing because of fraud? Now, if it's a fraudulent transaction and I rejected it, I made the right choice. I didn't lose anything, and I didn't make any profit. I didn't lose $500. I didn't make a profit of $15. It's zero. So, okay, this is a case where it's zero. Fine. But if it's a valid transaction and I reject it, I'm going to end up paying for that one way or another in the long run, at least with some customers. I've lost goodwill. They may choose to move from Visa to MasterCard or from my Scotiabank Visa to a Toronto Dominion Visa or something like that, move to another credit card company. And I'm going to lose in the long run from them. They may take other business away from me and not trust me. So I should assign a value to it, but I don't know how much. I don't know. Would $30 make them happy if I gave them some money back or did something for them? Uh, that uh, they haven't done that for me before, but I don't know. I don't know if banks actually would do that. They generally aren't nice in giving extra money out. But there is a cost in there. They just don't know what it is. But let's throw it in there, even with that imaginary number in there. So what do we get? So I'm going to take the value times the probability. The outcome, $15 profit, happens 98% of the time. $500 loss happens with probability 0.0002, very small. That $30, that in that loss of goodwill, 0.0099, and the other one, 0.008. I think one of the numbers is wrong here. Maybe that's 0.002. I think I have too many zeros somewhere. Anyway, I work it out, and if my math was right and my arithmetic was right, I get a profit of $13.40 as being my profit. Okay? Is that a good figure? You do have an alternative in this one. We could have had the bank approve every transaction. So we should look at a baseline case. And I think we looked at that last class with a baseline case, but still it ended up with different measures for sensitivity and specificity and all those other things. But what do those mean in real dollar terms? Well, in this case, the expected profit would be equal to $9.85. So I have a profit that's $3 to $4 more if I use the model than if I don't use the model. So this looks quite attractive to me, that the model is generating an extra $4 or $3 per transaction. And given that there are millions of transactions taking place every day, that's millions of dollars. That's a really good return. That I should use the model then. So this seems like a good idea. This is, again, on average. It's not on any specific transaction, but an average across millions of them. With this one, I'd be cautious about believing the numbers. As I said, the $15 profit, the $500 loss, maybe. The probabilities that I've got in there, again, the incidence of fraud, I should have historical records on that, so I should be able to measure that reasonably well. My model, hopefully I've tested it properly, and this confusion matrix is a good representation of how often it's right and wrong. But that $30 for goodwill, that's rather suspect. That would $30 after the embarrassment and frustration of getting your credit card rejected, depends upon the circumstance and how much it was for and so on. But for some people, they would be just furious with that. Others, yeah, it's an inconvenience, but they get over it. What happens on average though? And can we actually put a dollar figure on this? And that's questionable whether or not a dollar figure really exists. So when you do have ones where one, possibly more, but hopefully it's only one, has a consequence for which you don't have financial data or you just can't measure in a financial sense, you may want to try sensitivity analysis and try various values and see if the answer changes. So we could try 30, let's try 50, let's try 100. You could experiment, Sensitivity analysis is something that you, if you did Quant 1 at St. Mary's, you would have done linear programming and a little bit of sensitivity analysis. And you might have asked, what would prices have to change before you would change your decisions? And this, I'd like to know, my decision is to use the model or not use the model. Under what conditions would I not use the model? So I could do that by building a simple, like a break-even formula. I'd have do nothing on the left. That's $9.85, not using the model. On the right, I've got the formula for my model, but now for goodwill, I won't put in 30. I'll just leave it as a variable, and I'll rearrange that and solve it. And if my numbers are right, and it just seems hard to believe this, I'm going to have to go back after class and check this. It's just too good to be true. It says if goodwill, the value of goodwill is more than $1,400 of making a customer upset, if it's going to cost me more than $1,400 for that customer, then I shouldn't use my model. I should just approve everything. But if the value of goodwill is less than $1,400, then my model is better. And you'd probably decide it's probably less than $1,400. That seems like just too big a number. But when you don't know the number, instead of asking, is it $30 or $50 or $100 or $500, this approach goes and just asks you, is it bigger than this value or less than that value? And if it's bigger, you do this. If it's less, you do that. Unfortunately, sometimes we use this in some models, if they were health models, and that if this was the patient dies, what's the value of a death versus doing some sort of treatment? And that, so accidentally or just because your testing isn't perfect, what happens? And sometimes we can set it up in such a way we can ask ourselves, are we willing to invest an additional so many dollars per patient? Okay. Um, that to avoid this situation happening, that's changing my model around. It's an implied value of the goodwill or that type of loss. But sometimes we use this to monetize non-monetary outcomes, or ones that we can't honestly measure in simple dollar terms. So expected value, really good if our decisions are ones that we're probably going to make more than once. And that's particularly the case in this course because we've been doing data analysis generally for repetitive decisions. We've got a lot of historical data on factors and outcomes, and we've been trying to predict outcomes. So because we've had so many of these, it means this must apply to lots of people or lots of situations. This situation has arisen many, many, many times before. And so it will probably arise many, many times in the future. This isn't one decision. It's going to be many, many decisions. And we should get over the fact, well, maybe not. But in a lot of them, we don't have to get too emotionally involved in it. And we can accept we're going to make the right decision most of the time. We're going to make the wrong decision some of the time, hopefully not often. And we've tried to come up with a way of balancing those right. We've got to make a decision. We can't avoid making a decision. So we've come up with a decision process, which may involve using a model or deciding not to use a model, that balances the outcomes of these two things as best we can. And in data mining, that's going to be a common situation. But there may be some problems you walk into that also involve risk where it doesn't repeat itself. That what happens when it's decisions you make very infrequently. And uh, the way people respond to risk and understand risk, some can clearly differentiate between repetitive decisions and what's the right thing to do on average, and the one-time decisions that you're making, and that there's no averaging. You're going to be right or wrong. It's a single outcome that's going to happen. They're very different types of decision-making environments, and you must look at risk and outcomes in a different fashion. Expected value is probably not a good criterion to use when it's a one-time decision. But it is excellent when it's a repetitive decision. The last class is going to be on deployment and conveying things, and I'm trying to speak to the issue of understanding how people understand risk is going to affect how you try to present your results so that uh, your audience understands correctly what the risks are and knows how to process those and monetize them or something in an appropriate fashion. Because if you don't lead your audience in the right fashion, some of them, because of their attitude towards risk, may reject your ideas out of hand because of the risks that's involved without fully appreciating it. You need to educate them to some extent. And then there are some instances where there is a lot of risk and you want to warn them about the risk, and they prefer not to pay attention to that. And you have a responsibility to tell them, hey, this is iffy. It's watch out. Anyway, so here are a few things, and I'll give you two examples. But there are a lot of different, and there's I wasn't aware of this before. A lot of experimental research done on presenting different situations to people and seeing how they respond to it. And we find that they aren't always rational, or they have. Make sure you understand how they're perceiving things. And this one is one that you should be able to understand well. So you're offered a betting opportunity, and I'm going to show it in two different ways. Both of them have the same expected value. I'm going to say, I'm going to flip a coin. I'm going to do this 100 times. That if it comes up heads, I'll pay you $2. If it comes up tails, you pay me $1. Okay? So you may have to pay me $1, but then the next time I'll probably, I may have to pay you $2 if you're ahead, and you'll go back and forth. But every time when you win, you get more than when I win. So in a sense, you should be coming out ahead. And most people would accept this bet because the expected value, $2 times 0.5 minus $1 times 0.5, winning versus losing, comes out as 50 cents. And I'm going to do this 100 times. So I'm going to get an expected value at the end of the 100 flips of $50. Sounds like a pretty good deal. Now, I may not get exactly $50. That's sort of a long-term average, but you might expect to get around $50. Okay, change it around. I'm only going to flip the coin once. Same coin. If it comes up heads, I'm going to pay you $200. Comes up tails, you pay me $100. It's got the same expected profit overall, okay, of $50. 200 times 0.5 minus 100 times 0.5. So overall, same result. Would people take the bet? Some would, but most won't. They'll turn me down. And because if they lose, they're going to lose $100. In the other instance, they're going to lose half the time, but they're going to win half the time. And because it's a whole bunch of low stakes activities, they'll cancel each other out. And so instead of being either minus 100 or plus 200 as being the outcome, it's probably going to be maybe between 75 and 125, or sorry, on average, you're going to get maybe between $25 and $75. You're probably going to make a profit. It's very unlikely you're going to get less than you're going to lose money. To lose money, I'd need to get, um, you would need to get tails come up about 65 times, heads to come up 35. Well, no. So if tails came up 67 times and heads came up only 33 times, so quite an imbalance with that coin. Only then would you lose, and you might lose $1 at that extreme case. And that's probably not going to happen. So, in terms of the expected outcome, there's more uncertainty, that there's a perception, and it's a valid one, of more risk. So, they've got the same expected return, but the $100 versus $200 bet, the $1 versus $2 bet, the big bet one carries more risk with it, and people wouldn't take it, even though the probabilities in the situation is the same, because one is a one-time decision and the other is a repetitive decision in a sense. That and there, as I said, there's a whole bunch of things, and in finance, it's a big thing that if you were investing money in a startup company, startups generally fail. Most new businesses fail, but if they succeed, they may generate huge profits. You've hit that next $2 billion firm. What was the one in Newfoundland, I think, a software firm that helped. It was bought out by the New York Stock Exchange, and I think for about $2 billion. Massive return. Started a decade ago as a very small business startup, but it's grown and became very, very, very big. But for every one of those, there's thousands of ones that fail. So to invest in that type of startup versus to invest in Nova Scotia Power or Emera, that would be viewed as being in a utility, a very low risk investment, but it has a more modest return, expected return. The startup has got to have a much higher expected return to compensate for the risk that's involved. And you'll see all of this in finance, but they look at those sorts of things. So in that regard, people may understand, it's rational in terms of the psychology of risk. But here's one that's a little trickier to understand. Suppose I offer you money that does have some risk. You could get $6,000 with a probability of 0.45. So your expected return on that is $2,700. Or I could offer you $3,000 with a probability of 90%. And so it's got an expected return of $2,700. Which one will you pick? Most people will go for the $3,000. They view that as a sure thing. It's got, for them, less risk. They're passing up on the $6,000, but rather have the expression is a bird in hand versus two in the bush. Rather have one thing for sure than a chance at several others. But if we change the probabilities so that there is only a chance of 1 in 100 of getting 6,000 and 1 in 50 of getting 3,000, so same still expected value between the two. Okay? That the chance of getting $3,000 is still, or sorry, 1 in 1,000 versus 1 in 500. That the probabilities are still one is double the other, um, and the returns one is double the other. Most people will go for the 6,000 because they don't think they're going to win anyway. In both cases, they're going to lose, is their expectation. So they figure they're going to walk away with zero. And if I'm just going to gamble, then they go for the 6,000. And we see that with, why do people bet on Lotto Max instead of scratch and win or the ones you flick open or what have you? All of those lotteries have the same expected return. They turn back about a third of the proceeds as prize money, and a third goes to the corporation, and a third goes to expenses, commissions to the retailer, and printing and technology, that type of thing. And so the expected return of buying, a whole bunch of scratch and win tickets versus buying several Lotto Max tickets may be the same, but still you get lots of people buying those Lotto Max tickets, and especially if the jackpot is big like it is now, I think at over 50,000, that because they're viewing, I'm buying it because it's a chance at a dream, but I don't expect to win because it's just a dream. And so their attitudes towards those risks are different again. And you've got to think about those sorts of things. And everybody's different. Some people play lotteries and some will never play lotteries. When you're presenting your report and you're thinking about the decision makers that are going to decide on this or not, do you have a sense of what their risk-taking behavior is? And um, and the same manager may be a risk taker in some situations and risk averse in others. And we do find people are not consistent in their decisions. Um, that some managers, particularly if they see it benefiting them personally if they're successful, or of harming them personally if it's unsuccessful, um, do they realize the rewards or the costs? Um, where do they fit into that? So you've got to think about it. And so when you're presenting your recommendations, it is important that you convey that you don't have the perfect answer. You may be wrong. That they may not be making the right decision or the right decision every time. But you need to be able to explain what the risks are, how you're mitigating them, how you've measured them, um, defending your outcome, and that you have to be cautious. If you give too much attention to the risks, you'll have some of the risk averse people getting scared and running away and not approving, not acting upon your recommendation. And because you've made them too anxious. I can think of other instances where I've seen recommendations presented where they've downplayed the risks um, inappropriately, and the projects have ended up failing, and people are shocked that they failed, and it's because they should have known the risks there, but they weren't accurately presented. That there was a lot unknown that uh, they sort of glossed over that way. But I've seen it go both ways in terms of folks that are incredibly risk averse and others that, at least possibly unknowingly, were taking unreasonable risks. But you need to present that in your report because you need to be honest. And if things go wrong, uh, you need to be able to cover yourself in terms of what your recommendations were. Uh, People will always remember when you were wrong. They won't always remember when you're right. And that takes us to the end of today. So, hey, it didn't even go an hour. Um, I don't know if you've got, I can't remember. Oh, it was only Victoria was here before. Now there's Matt. So there's two of you. Um, I want to know whether or not you had any questions yet on assignment 5. If so, I can speak to them now. If you haven't gotten into the last assignment, please try to do it by Wednesday, and then I can do like I've done with previous assignments, and we will deal with your questions about the assignment and any issues you've got with it before I get in with the lecture material for what we've got on Wednesday. That Wednesday we're doing the last piece of actually trying to sell our recommendations. We're doing deployment, and a number of aspects of deployment we can't really get into because we don't have a real project in front of us to talk about. But I can talk in general terms about persuasive reporting, um, uh, how to, at least with data information, how to convey that appropriately to your audience, and some of the common mistakes that are made or bad moves, and some better ways of presenting stuff. Uh, and it's not necessarily simple. We've already seen some of it with when we did pivot charts, that how you're organizing the information. But I'll talk more specifically about a range of charts we've seen through the course and things that people may or may not do in presenting that data. And also presenting it in the context of storytelling, because that's what you're going to be doing. And if you haven't heard already, you're going to be hearing a lot more and more about dashboards and data visualization, um, which has got a lot of hype these days, but it isn't always clear where is that appropriate and where not, and what's the objectives and purposes of it. So I'll talk a little bit about that as well, unless we use up all our time talking about the assignment. Um, our last class is supposed to be Monday, but the Thursday class doesn't have a class on Tuesday. So Monday, I think, is the end of all courses, if I remember correctly. So unless we feel a real need on Wednesday, I probably won't have a class on Monday unless people ask me to. And I'll try to wrap things up as much as I can on Wednesday. And then you've got the quiz and the assignment, and you're done. And I'll try to wrap up all my marking and give you some feedback before the 15th, when I hope that's my target day for submitting grades. So there we are. Uh, any questions? Or Victoria, have you left me now? Matt, you still there? Oh, Danielle, I've got someone else. They're typing. I think they're typing. When's the final exam? That keeps coming up. That's the nice thing about the course. We have no final exam. You're finished. On Saturday, you're done. Uh, so, yeah, you've got crunch time in other courses. And really? Yeah. You've done it. You've done everything. No final. That if we go back to what I've just been talking about expected value, rather than having a course with a midterm and a final and a set of assignments. In your traditional format for a management science course is 50% final, 30% midterm, and 20% on assignments. And you have several assignments. So the assignments are low risk, but they're also very low value. And you have two high stakes, high value activities, a midterm and a final. You blow the final, you've blown it in the course. It's just so much uncertainty, so much risk. It's like the betting on, you know, flipping that coin. And if it's heads, you get $200. If it's tails, you pay me $100. Most students don't like that. So you've got 12 low stakes, very low stakes quizzes where you even get to attempt questions twice. So that's as low risk as possible, but the stakes are very small. They're only 2 points each, and I take the best 10 out of 12. that the tests, you've got 5 at 6 points each. So it's almost the value of a midterm, but it's spread over 5 of them. And so again, lower stakes and less risk in that regard because it's being spread. And I've got to go through, and finally I've read through many of the discussions so far in the course, but I haven't graded that. I had planned on trying to have a grade to you by mid to late October, but I can't keep up on grading assignments and so on. So anyway, I've got to grade that yet. And if you've been an active participant in most of the discussions we had earlier in the course, I've not been using them lately. I apologize for that. That I'll replace your lowest test score with that discussion. So again, it was something to mitigate risk again in that. And then you've had the 5 assignments. And those have actually been your high stakes activities, but you've had opportunity to ask questions. Whereas on tests, uh, tests are exams, higher risk because you really don't get much chance to ask questions and get clarification. Assignments you do. Um, so uh, this it's turned out to be an appropriate strategy for COVID, but actually it was the route I was moving the course regardless. Last year we didn't have a final exam either, didn't have a midterm. And I don't plan on having final exams in future courses, whether they be face-to-face or online. Uh, and, I think these tests and quizzes are more than adequately evaluating your understanding. So anyway, I'm babbling on again. Uh, any other comments before we close for today? If not, you'll see me on Wednesday. You guys take care. Bye now. I'm going to check and see who's here. Do we actually have? Oh, Avery's here too. All right. See? Uh, but not many. All right. Bye now. Take care.